Alright, now I want to say a few words about systems of differential equations. So although this topic is not important now, but it will be important later, so it's better to mention it now, so at least you are familiar. Basically, if instead of just a single differential equation, if you have a system of two differential equations, so that we have two unknown functions, x and y, both are functions of t, but the right-hand side of the differential equation, so notice that the right-hand side of our differential equation does not have t, so it is a completely function of x and y. So then, if we take these expressions f and g and combine them into a vector field, right? So just the first component is f and the second component is g, then we get the direction field of the system of differential equations. Because of the same logic, if we plot the solution as a parametric curve on the plot on the plane xy, then the direction field at every point is going to be tangent to the parametric curve. Right, so here is an example. Right, so here if you plot the vector field whose first component is 2y and whose second component is minus 3x, then you get these arrows that you see now, and then if you plot trajectories on top of this vector field, then you will see that these trajectories kind of also follow the arrows, and they are going to be tangent to the arrows at every point. Alright, now it is possible to convert every single differential equation into an autonomous differential equation, into a system of two autonomous differential equations. Basically, we need to introduce a dummy variable t, right? So we let both x and y to be functions of t, but then the first equation of the system is just x equals t. So very simple. And then we get the system dx dt is 1, because the first equation basically tells us the same thing, that x is t. And the second equation is just the same thing as the original one. The only thing that is different is now that y prime is interpreted as dy dt rather than dy dx. So it is probably not clear now why this is important, and maybe you shouldn't think too hard about it, but let me just mention that the reason why when we construct the direction field of a single differential equation, the first entry is 1 is just because of this, because it comes from this procedure of converting a single differential equation into a system of autonomous differential equations. So it is kind of nice to do it for a separable differential equation, because basically if we have a single ODE, we can do it differently. So we can, if the right hand side of the single ODE is g over f, then we can introduce this new variable t in a different way, and then the left hand side becomes just two different derivatives, dx dt and dy dt, which of course in general is not really much simpler than the original differential equation. But if the original differential equation is separable, then it means that we get a very simple system, and that's kind of another way to think about separable differential equations.